Okay, boys and girls, I'm Dr. Lo. So we will continue our lesson. Lesson number 26, specific heat capacity. Okay, before we continue, we recap a bit about the chapter about this subtopic lah. Okay, so at here, what is specific heat capacity? Specific at here, we are meaning step 1 kg. Okay, specific heat amount of heat that we needed. Okay, heat capacity. The symbol is C. Okay, then you have to know, it's very important, you have to know the definition of specific heat capacity because IGCSE they like to ask definition for this part. Okay, so what is this specific heat capacity? So you have to mention amount of heat needed, okay, to raise the temperature of 1 kg substance, increase the temperature by 1 degree Celsius. So your definition have to consist of these 3 points. Amount of heat needed to increase the temperature of 1 kg substance by 1 degree Celsius. Okay, so at here, if you saw that the specific heat capacity for water, it is 4,200 joule per kg per degree Celsius. Okay, example aluminium, it is 900 joule per kg per degree Celsius. Okay, what does it mean for the specific heat capacity? Meaning that water in need 4,200 joule in order to increase the 1 kg of water by 1 degree Celsius. Compared to the aluminium only need 900 joule. So that means that aluminium actually smaller c, then it can be heat up faster. Every 900 joule of heat, it can heat up. Okay, it can increase 1 degree Celsius. Then after that, how about the cool down? If let's say aluminium and water both are already raise the temperature until 100 degrees Celsius. Now I'm going to let it cool down. So every 900 joule, they release the energy of 900 joule, they will decrease 1 degree Celsius. So that means that it can heat up fast. Of course, it will cool off fast. Okay, so for this one, C small, heat up fast, cool off fast. This one actually you will find that most of the metal, they were having a lower specific heat capacity because this heat up fast, a good conductor of heat. Okay, then for water, 4,200 joule. This one, everyone, you want to increase 1 kg by 1 degree Celsius, you need to absorb 4,200 joule. You're only able to increase 1 degree Celsius. So that means that for water, specific heat capacity is quite high. Okay, so it will heat up slow and then cool off also slow. So if you boil the water, using kettle boil the water, you found that roughly you need to have 10 to 15 minutes. 10 to 15 minutes, you only can boil the water. Then you let it cool off. Then maybe after like 2 to 3 hours, you come and touch the kettle again. You will find that the kettle still warm. Or maybe the temperature quite high. Okay, so it will cool off slow. Okay, so this concept you have to be very clear. Okay, when you are a designer trying to choose the material, so you have to ask yourself, you want to heat up fast or you want to heat up slow? Okay, so with this knowledge, then we continue. We recap already what is specific heat capacity. So we comes to the page number 9 right now. Okay. Page number 9 is how we do the experiment to determine the specific heat capacity of aluminium. So just now I told you, aluminium is 900 joule per kg per degree Celsius. Teacher, how you know? Okay, yes, we know because we can do the experiment and find out the C value. How the experiment we conduct? Okay, so this is a later we have the video. Okay, this is a aluminium block. Okay, with 2 holes. One hole is for us to put the heater. So this is heater to heat the aluminium. Okay, so the heater is it have the power supply. Then this is the part for us to put the thermometer. And then because you see the thermometer here only a small contact with the aluminium block. The thermometer have a small contact with aluminium. So the conduction is not that good. What should we do? We can put few drops of oil, helping it to have a better conduction, okay, better conductions. And then we will have the cloth at here, outside here, wrapping. Okay, why? Wrapping at here and also the polystyrene is because the aluminium is a metal what? It will be transfer heat to the surrounding. When it get the heat also can be transferred out through here to the surrounding. But we don't want heat loss to the surrounding. So what should we do? We wrap it. Okay, wrap it by using the insulator. Help to trap the heat lah. We cannot stop all, but we can trying to reduce this problem. Okay, so the experiment is previously when we talk about the formula for involved with specific heat capacity, we got two. One is called E equals to mc change in temperature. Okay, then the E is the energy, but sometimes it doesn't provide the energy directly. They tell you that hey, we supply the heat by using the heater. Heater power rating is blah blah blah. Okay, we heat up for 10 minutes. So how can we find the energy? So last week I did mention P times T, E P T. Still remember? E actually is PT. So this one, E is equals to P times T. Okay, E equals to P times T. This one. Okay, don't forget that energy is in joule, SI unit. So the power must be also SI unit, which is which is watt. You don't, if the question give you kilowatt, please convert the kilo. Kilo is a prefix, okay? Then this one, the time, if the question give you in minutes, we have to convert it into second. Okay? Then here, the specific heat capacity is what we want to find. The specific heat capacity in final it will be in joule per kg per degree Celsius. So if here is in kg, so please, this one must be in kg. If let's say it is joule per gram per degree Celsius, then your mass should be in gram. So there must be tally lah, this part. Must be the same unit, okay? It depends on the question. It might be giving you, hey, the water specific heat capacity is blah, blah, blah. Then joule per gram degree Celsius. Then your mass in the formula at here, we should using gram to tally. Okay, but right now we want in kg. So please make sure your mass in kg. And then change in temperature. Please make sure you're using the higher temperature minus the smaller temperature. Okay, smaller temperature. Okay, the experiment, since we need what we need, we want to find C, that means that the rest of the information we need to have. So first, the mass. You need to measure the mass of the aluminium block, okay? So using what? Using balance to measure the aluminium mass. Then you have to find the change in temperature. Initial temperature, you need to know after heat up, then what is the final temperature. So you need two temperature, only can find the changes, okay? Then at here, your initial of course will be lower because this one is we heat up, okay, heat up. So we should using the final minus initial to find the changes of temperature, okay? Then this one is, okay, so we measure the initial temperature. Then we heat up, okay? Heater is switched on. At the same time, so we need to start the stopwatch. I need to know how long I heat it up. From here, I only can know that how much energy supplied by the power supply. Okay? Then after that, after 10 minutes, I measure the final temperature. So from this information, I can know the energy by finding power times the time. So the power for the heater that should be given in the questions. Okay, then the time is depends on how long we heat it up. Okay, of course, if you heat 5 minutes, less energy supply. If you heat more 10 minutes, then you will supply more energy. This one is for sure. So amount of energy is depends on how long the time you heat it up. Okay, so here M is we measure by balance. Then change in temperature is initial temperature have to record, final temperature have to record. Then we find the difference in between them. Okay, this is how we find the C. Okay, this is how we find the C for the aluminium. We just put all the data in, then calculate the C. Okay, before I forget, okay, I want to tell you, okay, we no need to memorize the unit for the specific heat capacity because you will feel that, oh, so hard. Okay, how do I remember? How can I remember the unit? No need to memorize, dear. You see, E equals to mc change in temperature. You rearrange it, becomes C equals to E divided by m change in temperature. Okay, what is the unit for C? Ask yourself, what is the unit for energy? It will be in joule. What is the energy in mass? It will be in kg. What is the what is the change in temperature? Temperature, so it's in degrees Celsius. Okay, so if we combine this, it will be joule per kg per degree Celsius. That is the unit for C. No need to memorize. We rearrange the formula. From the formula, we know the unit. Okay, then let me show you the video how it conduct the experiment. Okay.
This experiment aims to measure the specific heat capacity of aluminium. Measure and record the mass of an aluminium block. Wrap the block with cotton wool. Add a few drops of oil to the holes in the block. Insert an immersion heater and a thermometer into the holes. Place the block on a polystyrene tile. Record the initial temperature of the block and the initial joule meter reading. Switch on the heater. Switch off the heater when the temperature of the block has risen by about 10 degrees Celsius. Record the final joule meter reading and the highest temperature reached by the block as the final temperature. From the recorded data, the specific heat capacity of aluminium can be found.
Okay.
English is my second language, and I always have so many ideas in my head, but I find it hard to organize.
Okay, so come back to here. All the process is already procedure how we do it. Okay, is what I already explained. So assume that we get this experiment result. The power for the heater is 50 watt. The time we heat up for 10 minutes. But as I told you, you don't forget that to convert it into second because power times time, that is energy. Energy in joule. So your unit for the time, it should be in second. 10 minutes times 60 seconds, so you will get 600 seconds. Okay, you write down. So scroll out a bit here. Okay, is it here? Okay, boys and girls, now I want you try to do calculation to get the specific heat capacity using the data that I provided. Okay, can you try to calculate what is the specific heat capacity of the aluminium from the experiment data? Okay, do your calculation right now and then tell me your answer. Before I forget, this Saturday night, is it night? I said night. Yes, at night. There will be our replacement class for the Chinese New Year. That means that next week, Thursday, we don't have class because Chinese New Year.
Miss,
Okay?
like this Saturday as in like the upcoming Saturday after
Yes.
today's that one.
Two days later.
Okay.
I will send out the worksheet. I hope maybe tomorrow lah. Today I don't have time. So tomorrow, let me get ready for the worksheet, then I send it out. So Saturday we'll use the new worksheet. We'll enter new chapter. Okay. So I did send out the homework 1 and 2. Actually, if you scroll down the bottom the last few pages, actually is the answer and my working step. So you can try and practice it. Okay, did you guys get the answer for the specific heat capacity for the aluminium? Can you tell me? Specific heat capacity. None of you get calculate the answer? Tell me your answer. Hui Tong, tell me. Danielle, Angeline, Serene, Bora. What is your C? Value of C from this experiment? Hui Tong, yes. Hui Tong, remember 2 to 3 significant figure. Okay, so at here, I can just using PT equals to MC change in temperature to do calculation. Then after I do substitution, I only move here and there. Okay, so this one is 50 times 600 equals to 1 kg times C unknown. Then this one is 54 minus 31. So my specific heat capacity for aluminium in this experiment, we will get 1,300 joule per kg per degree Celsius. Okay, so this is our C from the experiment. But do you remember just now I did mention, hey, aluminium is 900 joule per kg per degree Celsius. Teacher, why is different as what you say 900? Why I calculate from the experiment I get 1,300? Okay, for this page, have you done? If done, give me the response. Then I will go to the next page and explain why not 900. Why from the experiment is 1,300. Okay, Serene, okay. How about others? I worry you still writing. Wei Tong, okay. Megan, okay. Okay, Angeline, okay. Okay, dear, we goes to here. We goes to the third one first. Given that the specific heat capacity of aluminium is 900, but we found out that the specific heat capacity for the aluminium that we calculate from the experiment is larger. From experiment, we get 1,300 joule per kg per degree Celsius. It's larger. Why? Okay, now dear, look at here. This is from experiment. Okay, experiment here. The initial temperature is 31 degrees Celsius. Final temperature is 54 degrees Celsius. Changes in temperature, if not mistaken, 23 degrees Celsius. It will change 23. Okay, in ideal case, perfect, everything perfect. Okay, so here, initial temperature is 31 degrees Celsius. Final temperature. Okay, dear, can you see that our experiment setup? We're using the cloth to wrap it. We're using the polystyrene board at here. All that we want to do is trying to reduce energy loss to the surrounding, the heat loss to the surrounding. But I say reduce. We cannot 100% prevent it losing to the surrounding. Cannot. We're trying to reduce. So at here, if perfect case, meaning what? No heat loss to the surrounding. Okay, no heat loss to the surrounding here. Well, I cannot write the G. Okay, here. So, boys and girls, 31 degrees Celsius. Now with perfect case, all the heat from the heater going to the aluminium. My final temperature should be higher or lower than 54 degrees Celsius. It should be higher or lower. What do you think, this part? If ideal, perfect, everything perfect, all the heat goes to the aluminium block. No losing. So my final temperature should be higher or lower than 54. What do you think? Can somebody give me? Respond to me, dear. If not, I'm the one to talk here for 1.5 hours. Somebody respond me. So what do you think? It will be higher or lower? If everything perfect. all the heat from the heater will goes to the aluminum block. Okay, it should be higher. Am I right? Because all the heat giving to the aluminum one. So it should be higher. If higher, so let's say I set 61 degrees Celsius. So my changes in temperature, it should be 30 degrees Celsius. So when we compare, can you see that this one change in temperature, the rise in temperature actually is smaller. Okay, temperature rise actually smaller. Am I right? Then just now we did saying C equals to energy divided by MC, data, M change in temperature. Okay, dear, you see, when this reading change in temperature, rising in temperature here is smaller, this part, if let's say this one small, what happened to your C, your mathematics? A value divided by a small value. So your C should be high or low. Should be high or low. High. So this one, your C at the end, you will get a high C. You will get a high C. Okay? So this is the reason why from the experiment we get 1300 joule per kg per degree Celsius. Then from here, if the change in temperature, you see, this one divided by a larger value. This value is larger, so your C will be smaller. So it will be 900 joule per kg per degree Celsius. Okay, so at here, we need to explain why from the experiment is larger than the standard value. Why? Okay, so we answer here is because some heat is lost to the surrounding, resulting in the rise in the temperature being less than it should be. Okay, so at here 2 point, why? It's because heat loss. Then your rise in temperature will be small rising. So these two point will let you have 2 marks for this kind of question. If 1 mark, then it's fine. Some heat loss to the surrounding sector. Okay, some heat energy loss to the surrounding sector. But if 2 mark, we should explain about this smaller rise in temperature. It will rise in temperature less than actually it should be. Okay, so this is the reason why from the experiment is higher than the actual standard value. Okay, 20 seconds for you to complete this part. Two mark, 1 mark is heat loss. Second mark, you can mention about the change in temperature, smaller change in temperature, small rise in temperature. Okay, these 2 mark. So have you done for this part? If yes, can you give me response? Then I comes back to the question 1 and 2. No response, that means that haven't complete yet, Oh, Emily, yes. Zihua, yes. Angeline, yes. Good job. Serene, done. Okay. Bora, yes. Okay, dear, here. What is the purpose having the tissue paper, the cloth? Okay, no matter it's tissue paper or cloth, doesn't matter. And polystyrene, this one is 1 to reduce. Okay, so here we write to reduce heat loss from aluminium cylinder to surrounding. Okay, so it's more easier to reduce heat loss to the surrounding sector. Okay. Okay, why we need to put few drops of oil into the hole for housing the thermometer and immersion heater, but most of the time we just putting in the thermometer, like it depends on, okay, depends on the instruction. Okay, here is just now I told you to have a better conduction. Okay, so it's here to improve the conduction of heat from the heater to the thermometer through aluminium block. Short form, to have a better conduction. Okay. Okay, finish. If finish, then we go into the page 11. So now we study about aluminium. Page 11 is we find the specific heat capacity for water. Okay, so here, Angeline, okay. The rest of you, okay? I'm going to the YouTube day, play the video for the for the specific heat capacity for liquid. So this one.
Capacity of This experiment aims to measure the specific heat capacity of water. Measure about 0.2 kilograms of tap water using a polystyrene cup and an electronic balance. Insert a stirrer, a temperature sensor, and an immersion heater through the holes in a lid and into the cup of water. Connect the heater to the power supply via the joule meter. Record the initial temperature of the water and the initial joule meter reading. Switch on the heater. Stir the water gently and continuously. Note the temperature change of the water. Switch off the heater when the temperature has risen by about 10 degrees Celsius. Keep stirring the water. Record the final joule meter reading and the highest temperature reached by the water. From the recorded data, the specific heat capacity of water can be found.
My wife said, if you
What
win,
is
we'll
that?
fly to Asia. If I win, we'll fly to Paris. I bet you won't get
Advertisement. It's none of my business. Okay, here we
I
come
think
back
that's
to the.
AI.
I don't know. Okay, so sexy. Okay, dear. Next goes to your page 11. So how you are going to measure the specific heat capacity of water? These amounts actually doesn't matter if you're using 500 gram or 300 gram, doesn't matter. Okay, the answer at the end still to be the same. We measure the initial temperature, then we switch on the heater, then we start the stopwatch, then we will stir continuously, make sure the temperature throughout the liquid is uniform. Okay, one of the year of the IGCSE, they're asking you why we need to stir. So this is the answer. Okay, after 10 minutes, the temperature of water is read from the thermometer and recorded. The increase in temperature, you're using final minus initial because this is heat. We heat it, so of course the final will be higher temperature. Okay, so here same thing. You see, we will wrap it. So we want to trying to prevent the heat loss to the surrounding. And then if you want to make it more perfect, actually here we still can add the lid. Okay, here. So this one you can add. Then what else? Polystyrene at the bottom part at here. Okay, we're using the polystyrene cup. Do not using the metal. Metal is easily to conduct heat to the surrounding, to the table. Okay, so we will have a stirrer. Keep on stir it up down to stir the water. Make sure the water temperature throughout the water is actually temperature is the same lah. Okay, so here just now based on my instruction here, we are measuring 200 gram. 200 gram. Okay, dear, just now I did mention, right? If the C that we want to calculate is in joule per kg per degree Celsius, so please make sure your mass at here, your mass, it must be also in kg. So this one, please convert to kg, it will be 0.2 kg. Okay, 0.2 kg. Heating time, we heat it for 10 minutes. So again, the P times t, this t, the time must be in second. Okay, so this one will become 600 second. Can you guys help me to do calculation? What is the, oh dear, this one, cancel, I copy and paste. This is should be water. Specific heat capacity for water is calculated as follow. So this one, water is equals to your final answer. What is your final answer? Joule per kg per degree Celsius. Okay, do your calculation and then tell me. Angeline, yes, dear Angeline, correct. The rest of you try to do calculation and then check whether you can get this value or not. So PT equals to MC, change in temperature, power is 50 times 600, mass is 0.2, C unknowns, temperature increase 59 minus 34. So C should be 6,000 joule per kg per degree Celsius. Okay. Is it okay? If okay, then we are going to the page 12. We try with the past year question. Yes or no? No response, so haven't finished. Or Hui-Tong okay, Zihua okay. Okay, Serene okay, Bora okay, like dear. Question number 1. Okay, energy A, B, C, and D. Okay, dear, can you try? I want to go toilet for a short while. You try do calculation. Then after that, you tell me that what is your answer in the chat box here. I goes to the toilet. Okay, I'm back. Angeline. Yes, correct, dear. Good job. Okay, so here power is 50 watt. Okay, dear. When you look at the unit, you know this is power. So write P. The mass, this is M. Write it M. Then initial temperature, delta I. Then it switch on for 2 minutes. So this is time T. Record until the temperature stop rising. Highest temperature, this is final temperature. Okay, what is the energy supplied by the heater? It doesn't tell us the heater. It doesn't tell us what is the energy. Okay, so what should we do in order to calculate the energy? Bora, correct. Good job. So I told you, E in Chinese we say EPT, right? E equals to P times T, okay? PT, E equals to PT. When we study about work, energy, power, that chapter we also learning about this formula one. It's not a new formula for us, huh? Okay, then the power is 50 watt. The time is 2 minutes. Don't forget, your final answer here is joule. It's SI unit. So your time should be in second also. So this one, 2 times 60. Make sure in second, okay? So your answer for this is 6,000 joule. Don't forget formula, substitution, final answer with unit, okay? Okay, then question B. Have you get the answer? Specific heat capacity of the sand. Calculate a value for this. So I know E equals to mc, change in temperature. The energy way we get here just now in A. Sometimes the A and B, they will be related. They guide you for certain value first. Then actually you're using this value from the A goes to the B. Okay, so please make sure you do calculation correctly. If here you do calculation wrong, then at the end you carry the error to the next question, you only can score 1 mark. We call it as error carry forward mark, ECF. Okay, the final answer you will lose. So here 6,000 equals to the mass 550. 0.55, dear. 550, you should convert to become kg, 0.55. So this one should be in kg. Why I need to be in kg? Because here, joule per kg per degree Celsius. We write the answer in joule per kg. So C is unknown. Change in temperature. 33 minus 20. So if you do everything correct, the sand specific heat capacity for the sand should be 839 joule per kg per degree Celsius. Or we accept the answer 840. 2 to 3 significant figure. Bora, correct. Yes, good job. Okay, so it should be 2 to 3 significant figure. Okay, don't give me 800. You will lose the final mark. Okay, so this one 839. Okay, until here, is that clear? A and B should be fine. Then we have to discuss, Angeline, thank you. We goes to C. Okay, here. Explain why specific heat capacity of sand may be different from the value that you calculate in B. That means that the standard value, it might be different from your what you calculate in B. Calculate in B actually is experiment one. Okay, so here 2 marks. Of course, one of the most important marks, we can say that the points, we can say that some heat energy lost to the surrounding, right? Okay, so here one more point we have to think. Then standard value actually it should be higher or lower than what you calculate in B. So at here we can say that specific heat capacity, it should be lower than 839 joule per kg per degree Celsius. It should be lower than this value. Okay, why? It's because some energy lost to the surrounding. Some heat energy, no, more clear, some heat energy lost to the surrounding. So your standard value for specific heat capacity should be lower than what we calculate just now from the experiment data. Okay? Okay, for D here, this is the main point why I put this question in the worksheet. On a sunny day, temperature of the sand is much higher than the temperature of the sea. Explain why. 2 mark here. Okay? So, any of you can tell me why? Why temperature of sand on the beach is higher, is much higher than the temperature of sea? Why? Tell me why. Any of you can tell me why? Angeline, yes, come. Sand layer has a lower specific heat up capacity. Yes! You need to talk about specific heat capacity. Okay, first point, on a sunny day, the sand and the sea, are they receiving the same amount of heat energy from the sun? My answer is the sun is there, so it supplies the same energy of heat, am I right? But why sand will heat up faster? Because temperature higher, why it heat up faster? So you have to explain about the specific heat capacity. Okay, it heat up faster is high or low specific heat capacity. That is the things that we already just now starting we did recall here. You see, if your C is lower, it will heat up faster. Although I supply the same heat to the water and same heat to the aluminium by using the heater, same time supply the same heat. But we found out that aluminium will heat up faster. So it will have a higher temperature. Okay? So this one, we should answer like this. Why is much higher? Okay, first point, we have to say that they receive same amount of energy. Okay? So this one, same rate of energy supply to sand and sea. They receive same amount of energy, heat energy, but specific heat capacity of sand is much lower than the specific heat capacity of water. Okay, just now we did calculate, we say that the sand in our experiment is 840 joule per kg per degree Celsius. Then the water, as we know, the water is 4,200 joule per kg per degree Celsius. So dear, can you see that? This one small amount is enough. Small amount is already enough to increase the temperature. So sea sand is actually lower. So it heat up faster. So temperature rise higher. Okay. Ten seconds for you to 20 seconds for you to complete this. Angeline, okay already? How about others? Only Angeline done? The rest of you? If you're done, you give me response so I know that we can proceed. Zuhua, okay? Megan, Bora, Shireen, Hui Tong ne? Hui Tong. Emily ne? Emily able to follow? Yes. Emily, Megan, yes. Hui Tong ne? Hui Tong. Shuan, Danielle. Hui Tong, okay. Danielle. Okay, dear, we goes to your next question. Can you do calculation? And then if you're able to prove that mass of air in the room is 79 kg, then you press the reaction button. So I will know that you're able to prove it. Okay, so this one, heater, we use it to heat a room. Dimension of the room is 4.5 meter times 6.1 meter times 2.4 meter. Density of air is 1.2 kg per meter cube. If you're able to prove it, then you tell me, okay? Press the reaction button to tell me. Actually, 3 steps only. Formula, substitution, final answer. What formula you can use to find the mass? Angeline, okay already? Every time when you saw some information, then you ask yourself, what is the formula related to this? Density is mass divided by volume. Got mass got density Volume also can calculate. Then you can using this formula. So density is mass divided by volume. Density 1.2, the mass unknown because we want to prove. If we want to prove, we need to make this m as an unknown. Okay, volume in the room. So volume is 4.5 times 6.1 times 2.4. Okay, this one nothing difficult. So 79 kg. Okay, we proof. So this one should be fine using the formula of density. Okay, can you help me to calculate the B? How long the time is needed to increase the temperature from 16 to 20 degrees Celsius? Angeline, yes, correct. The rest of you, did you able to get the answer? This one also nothing to trick you. Actually, I put this question, I want to mainly discuss about the C. Here, nothing to trick you. So power PT equals to MC change in temperature. Power is 1100. The time, we don't know. How long I need to heat it up, okay? The mass. What is my mass? Mass is 79, okay? 79. A specific heat capacity is 1000. Change in temperature from 20 minus 16. So it's increased 4 degrees Celsius. Okay, if you did calculations, so your time should be 287 seconds or 290 seconds. Okay, 2 to 3 significant figure. Okay, so you see 4 marks. So formula must be there. Then substitution must be there. Sometimes is final answer 1 mark. You need 1 mark. Sometimes it's like this the answer scheme. Or sometimes is if you able to identify this change in temperature, they will give 1 mark at here. Okay, either is the unit or they give the marks at here either one. So 4 marks. No matter how many marks, please, formula, substitution, final answer with unit. Okay, here, the main points that I want to discuss is this. Suggest one reason why the time that we calculate, this one is in B. Okay, the time that we calculate in B is the minimum time. Okay, if let's say I'm the one tell you that, hey dear, we want to heat from 16 degrees Celsius to 20 degrees Celsius. I just need to heat 287 seconds. Then at the end, you follow me, then you start the stopwatch. You found that teacher, no leh, I took 360 seconds, only able to heat to 20 degrees Celsius. What you told me, actually I need a greater time, more time than this, what you told me. Why? Why the one that I told you is the minimum time for me to achieve from 16 degrees Celsius to 20 degrees Celsius. But when you do it, actually you will find that, hey, I need more than this time. Okay, why? Reason is why. Zihua say heat energy is dissipated to the surrounding. I want to give you wrong. For this question, wrong. For others question, yes. But for this question is wrong. If you say that heat lost to the surrounding, heat is dissipated to the surrounding, this question I will mark you wrong. Reason is this application is heater used to heat the room. So you are going to heat the surrounding air particle. You want to warm the air particle in the surrounding. So heat loss to the surrounding. This is what we want. This is what we want, okay, to warm the air particles surrounding us. So heat convert to sound energy wasted? No. Okay. Heat energy loss, but not loss to the surrounding, loss to where? You must have your furniture, your wall, your curtain, whatever, the what? The furniture, your table, your chair, whatever. So we still having some energy loss, but not loss to the surrounding, but loss to the all the item surrounding you. Okay, so for this question, so we write down thermal energy is transfer some thermal energy is transfer to, you can say furniture, you can say the wall, or you can say any object, any objects in the room. Okay, surrounding is what we want, but they goes to the table slightly higher temperature, so it already lost energy to lost heat energy to some way that we don't want. We want the surrounding air particle to be warm. So this is the part that I want to discuss. You have to depends on the situation. Okay, depends on the situations. Okay, so is that clear for this specific heat capacity? If okay, then give me a response. Then we will go to lesson number 27. Angeline, okay. Serene, okay. Megan, okay. Zihua, yes. Okay, dear. We comes to lesson 27. Changing stage. Okay, just now specific heat capacity is changing temperature. So I want to tell you that thermal energy, we supply thermal energy, they will have two works. One is either used to increase or decrease the temperature. Another one is we might absorb the heat, but we trying to change the stage. Okay, but this one is or only or cannot one times happen both. Either one, okay? Thermal energy that we supply either is used to change in temperature or we are changing the phase. Changing the phase means that from solid to liquid, liquid to gas. That is called changing of phase. Okay. Okay, here. So at here, when solid to become liquid, we need to absorb the heat. We supply the heat and let it melt. So this one is melting. The process is melting. Then I continue supply the heat to make it become liquid, become gas. So this one is, we can say that the process is boiling or evaporation also can. Evaporation also can. So at here, energy is absorbed. We absorb energy. So we can change from solid to liquid, liquid to gas. Okay, when we want to from gas to the liquid, we need to release energy. Release. So this process is called condensation. Then this one is called freezing. Okay. Past year question 1 is simple. Very simple. Then we'll go to page number 2. Okay, this part settle. Yes or no, dear? Okay. Thank you. So here, which change need a energy input? Okay, we need energy. That means that we absorb energy lah. So answer is this one, solid to liquid. Yes, we supply the heat. Okay, then Q, we also supply the heat. Then S and R is release. Okay, remove. So this one is release. So here P and Q is absorb. So answer should be A. Okay. Okay, Angeline, yes, correct. Bora, yes. Okay, here, dear. Goes to page number 2, So now this is a heating curve of water. We heat the water from solid, which is ice. So we're starting from ice here. This is solid, solid. So this part, A, B here, solid. Actually, ice is in solid. Okay, can you see that this part, temperature rises from -10 to 0. -10 to 0, actually we supply heat. So at here, in this stage A and B, they still solid, they still in solid form. They didn't change phase, didn't change the state, okay? So we look at this, we supply the heat, temperature rise from -10 to 10. Thermal energy is taken, used to what? Just now I told you we got two job. Increase temperature or we change the state. So at here is we absorb the energy to increase temperature. Increase the temperature. Okay. Then until 0 degrees Celsius. So we observe this part, section B and C. So for this part, you will find out that, hey, teacher, temperature remain at 0 degrees Celsius. Is it we stop supply the heat? My answer is no. We still continue supplying the heat. But teacher, why? Why it doesn't increase the temperature continue increase? Because at section B and C, they use the energy, absorb the energy, used to change the stage. Okay, change the phase here. So for this part, some of the ice, they start to melt. They start to melt. So some of the ice, they will convert from the solid become liquid. But some of the ice still there, some of them become liquids. Therefore, in the section BC, we got solid plus liquid here. But until point C, until point C at here, point C, it will completely all liquid. Here, point B is completely solid. In between them is solid plus liquid. Okay, we see temperature remain constant at 0 degrees Celsius. Thermal energy continues supply from Bunsen burner, but there is no change in temperature. Okay, there is a change of state, which is the ice is melting into the water. Melt, keyword melt, melting. So I know that is change the phase. Thermal energy is being taken in to change the stage. Melting point for the pure water is, so we look at this. This is the melting point. Melting point actually is the temperature for the solid convert to liquid. Temperature for the solid convert to liquid. So melting point at here is 0 degrees Celsius. From the graph, we know that 0 degrees Celsius is the melting point. Melting point is not a point, it's a temperature for the solid convert to liquid. Okay? During the melting, we absorb the heat. It doesn't increase temperature, but what it did, okay? The heat energy absorbed for what, okay? So for the solid, we understand, okay? We understand solid. The particle and particle, they are close together by a strong force. Am I right? Okay, like this. Oh, something like this. Whatever lah. Okay, you understand they hold by the strong force. But after that, liquid, okay, last time you asked me, you told me that your chemistry teacher will teach you touching. So touching or not touching for me is okay, but if you want to touch, then you touch it. But in random, then if you don't want to touch, my requirement is, well, let me redraw. Where my requirement is, if you're not touching, please make sure the distance between the particle, they are very small. Okay, for example, like this. Then like this. Okay, you can draw some of them touch also, never mind, like this. Like this. Okay, but if you didn't touch, I need you make sure the gap in between, they are smaller than one of the particle size. Let's say this is a particle size. So this one, the gap size must be smaller than one particle. You cannot fit one more. Okay, if the gap size is big like this, you still got some gaps able to fit one more particle. So that one will be wrong. So you need to draw randomly draw their position, but the gap in between, please make sure small enough. Okay, this is solid and goes to liquid. So here goes to liquid. But if solid, you have to complete all. Okay, here, and here. Okay, so there from solid to liquid, solid they hold by a strong force, okay, strong bond. So we want to change the phase. What should we do? We should break the bond, weaken the bond. Okay, maybe more accurate way is say weaken the bond. Okay, weaken the bond. So absorb the heat is used to do this task, weaken the bond. So we don't use it to change the temperature. So for solid, if let's say this is 0 degrees Celsius, then the liquid also at 0 degrees Celsius. So the water that melt from the ice is at right now at 0 degrees Celsius. Okay, is that clear? Yes or no? Is that clear, dear? Okay, sorry. Megan, yes, Bora. Okay, so here we melt until all the ice melting become fully or become liquid. Then at here, I still continue supply, Bunsen burner still on, so the temperature for the liquid will start to increase from 0 to 100 here, from 0 to 100. So between C and D at here, there is no changing of phase. Liquid still liquid. This part actually is related with what just now what we learned. E equals to mc change in temperature. So how much energy you supply, how many kg of the water, then specific heat capacity 4200. So we can know that temperature rise. Or here we want to rise from 0 degree to 100 degrees Celsius. 0 degrees Celsius to 100 degrees Celsius. We can count how much energy we need to supply, or we can count how long we need. Okay, so for the section CD is actually what we learned just now, specific heat capacity. Okay, so maybe at here I want to know, hey, from C to D, how long the time we need to heat it so that it can increase from 0 to 100 degrees Celsius. Then this is the formula. How long the time? You will know the power. You will know the mass of water. C is 4200. Then this one change in temperature from 0 to 100. So you can count how long the time we needed for this C to D process to be happen. Okay, so at here C to D is thermal energy is taken in to increase temperature. Okay, then here D to E here, you see, it will be constant temperature again for this part. Why? Change phase again. Just now is melting, now is boiling. So just now here melting, now is boiling. So at here at D point is still all the liquid. Okay, until here this one will completely, E point will completely become gas. Okay, so in between them will be the liquid plus gas. Okay, here again, why we absorb and we supply, we supply the heat by using the Bunsen burner. We supply the heat, so the liquid they receive the heat energy. But why temperature doesn't change is because here got two reason at here. Just now at here we understand is weaken the bond. Okay, then here actually got two reasons. One is we want to break the bond, of course, break the bond, completely break the bond. So it's from liquid to become gas, okay? So this is one. There is another one more reason. What is the reason? Okay, let's say this one is the liquid. Okay, it's trying to turn to become gas, am I right? So it's trying to escape out, escape out. But the problem is there is something pressing downward at here. Do you know what is this pressing downward? What is this pressing downward? There is something pressing downward. Okay, so it's not easy to go out, escape out. Can you tell me, any of you got idea what is the things that pressing downward? What is this pressing downward? Any of you know? Something is pressing on the surface of the liquid. Any of you know? Angeline? Atmospheric pressure. Yes, very good. Like there, write down atmospheric pressure. Atmospheric pressure pressing in all direction. So the liquid trying to convert to the gas, it need to overcome atmospheric pressure. Overcome atmospheric pressure. So because of these two tasks, they need energy. The energy supply is actually do these things, break the bond and overcome the atmospheric pressure. Therefore, the energy doesn't use to increase the temperature. Okay, it's different job. Okay, so 10 seconds for you to complete whatever I write. Finish. Can we proceed? Angeline, okay? Okay, so we come back to the last part at here. DE. Temperature still remain at 100 degrees Celsius. So the liquid right now we boil, it will become 100 degrees Celsius. This is the liquid. Boiling water 100 degrees Celsius liquid. So we convert it into the gas. The gas right now is also 100 degrees Celsius. Temperature doesn't change. There is no change in temperature even though thermal energy is still continue supply. Okay, Shuan? Okay, here. Wait our friend haven't. So 10 more seconds. Shuan, if you're done, let me know. Okay, so for this part, although temperature is still, although the heat energy is still supply, but there is no change in temperature because they use the heat to change the stage. So water right now is boiling and it changed to the steam. The boiling water, so from here, at what temperature it will boil. So this part is a boiling part. So at 100 degrees Celsius. So this one we write down 100 degrees Celsius, it will boil. During boiling, the particle in liquid, they still have a strong force between them. Of course, you compare to solid, it have a weaker force. But compared to gas, it still have a strong force. So we need energy to break the bond. Okay, dear, underline this or highlight this. Break the bond. So at here, we need to break the bond and then also require it to overcome atmospheric pressure. So here, these two reasons. Absorb the heat, change the state. How it change the state? It should break the bond. It should be overcome the atmospheric pressure. So that when changing the phase, there is no change in temperature. Okay, done? Done. Give me a reaction so I know that I can continue. Sihua okay, Angeline okay, Serene okay, Shun okay, Daniel okay, Shun okay, Bora okay. Shun, yes, okay, dear, Huitong, okay, good job. Dear, come back to here. You see, I told you, either one. Either increase temperature or change the stage. So actually, when changing the step, you need to identify from the questions some keyword. Okay, when you saw the keyword say melts, when you say the keywords boils, so when you say condense, then freezing, all these meanings that they're changing the phase. So if they change the phase, one thing is very important you have to know is their temperature is constant. Temperature is constant. Okay, if temperature constant, particle doesn't change speed. Important, particle doesn't change speed. So the kinetic energy is also unchanged. Kinetic energy unchanged, okay? So speed unchanged, kinetic energy related with speed. Temperature related with kinetic energy, they are related to each other. If you higher temperature, then the particle will have a higher kinetic energy. But here, because temperature is constant, so kinetic energy for the particle doesn't change. Of course, the particle doesn't speed up. When constant temperature, particle doesn't speed up. Okay? So until here, is that clear? Then for changing temperature, increase temperature, no change in phase. No change in phase. Solid still solid, liquid still liquid. If changing temperature, this one is the part that we learn. Energy is equals to MC change in temperature. This is the one that we learn in lesson 26. Okay, is that clear? Is that clear? Is it okay? Then I'm going to the page number 3. Megan, okay. Only Megan. The rest of you, if done, then let me know. Angeline, okay. Zihua, okay. Hui Teng, Shuan, Emily, Bora, Shireen. Shuan, okay. Hui Teng, okay. Emily, okay. Shireen, okay. Bora should be fine. Bora, yes. Okay, dear. We goes to page number 3. Just now is heating curve. Now is cooling curve. It will release energy. So for the part that decrease temperature, I don't need to mention lah. That is the part E equals to MC change in temperature. So we release energy, temperature will decrease. Okay. So at here, what I want to emphasize is the section BC, this part. Okay, this part is the part that they change the stage. So just now at here is gas. So right now at B point is still gas. But in between is gas plus liquid. Here gas plus liquid. And then comes to C is completely liquid. Comes to C point is completely liquid. Okay, at this part, they release the energy. They release the energy, condense into a liquid from gas, condense into the liquid. Energy is released, so the particle, they will become closer. Okay, they will become closer. Force will pull them closer. Okay, for this one, I want to emphasize is this is a condensation point, right? Condensation is the point that it will happen condense. The gas will turn into liquid. But this one actually also equals to the boiling point. Condensation point is actually boiling point. So if right now we want to using this substance to heat it up from the liquid to become gas, actually it also need to have this temperature to boil, yes, okay, to boil and then turn into the gas. So condensation point actually is the boiling point if we sketch the heating curve. In cooling curve, we call this as condensation point. In heating curve, we call it as boiling point. Okay? Then for the DE, okay, DE, this section, DE. Okay, so DE is solidifications, liquid plus solid. So point D at here still all the liquid, liquid. This one point C also liquid. Then they will start to have liquid plus solid here. Until point E, it will fully become solid. Okay, for these solidifications, they also release the energy. So they will be pull the particle comes to the fixed position to form solid. In this process, energy is released. That's all. Okay, this point we call it as freezing point. Freezing point, this point is called freezing point. But the freezing point, if we sketch it into the heating curve, we can call this point roughly 68 lah. Okay, 68 degrees Celsius will be the melting point. In cooling curve, it is a freezing point. In heating curve, this 68 degrees Celsius is a melting point. Okay. Is it clear for this part? If okay, then give me response. Then we try with the past year questions. Is it okay, dear? Am I explained clearly? Okay, Bora, okay. So here we comes to this 2016 past year question. Which statement describe what happened as ice at 0 degrees Celsius start to melt to become water? Angeline, yes. How about others? Daniel, can you try to tell me your answer? What do you think for this question? Ice solid start to melt to become water, become liquid. So which statement is correct? Emily start to melt. Dear, melt is absorb heat or release heat? Emily, think about this question. Serene, melting. You absorb heat or release heat? Melting. So ask yourself, melting point, melting. Yes, Serene, correct. Melt. Daniel. Okay, here, dear, you see, melt is from solid to liquid. So this one is melting, melt. Okay, we want to make the ice melt. We should supply or we should take the heat out from the ice. So answer is we should absorb the heat. The ice should absorb the heat, right? Absorb the heat. So answer should be A or B, absorb the heat. Then when melting, see, this is the keyword I told you at here. I come back to here. You see, when you saw the keyword of melt, boil, condense, freezing, meaning what? They changing the stage. When they're changing the state, what happened to the temperature? Temperature is unchanged. So we come back to this question. It start to melt. So this one is change the stage. So here, temperature unchanged. Temperature is constant. So our answer for this question, it should be A. Okay, so 2 points. Ask yourself, absorb energy or release energy? The ice should absorb energy, absorb heat, or actually the ice should release heat. So since we melt to become liquid, we need to absorb the heat. Then absorbing the heat, but temperature still remain constant, is because they changed the phase. They didn't use the energy to increase temperature. Okay, is that clear for this question? Can I go to the question number 4? So what question number 4? Page number 4. Can we go to page number 4? Okay, Daniel, okay. So the rest of you is okay? Can I move? Okay, okay, dear here. This is 2015. A solid is heated from a room temperature. Then the graph shows how its temperature change with time as it is heated constantly. At which time has it just become completely liquid? Like dear, try. They say starting is solid. At which point it will become completely liquid? Bora, yes, correct. Angeline, yes, correct. Daniel, in between here, this part is solid. Then this is melting. Here is melting, melting. So it will have a solid plus liquid. So where is the point of liquid completely become liquid? When horizontal is they still changing the phase. So what do you think, Daniel? At A, B, C, D, which one is completely become liquid? Just become the liquid. So here is still solid. Then in between, they will have some liquid, some ice become liquid. Okay. Then after that comes to the point C at here. You see, it start to change temperature. So at here, it will all become liquid. So all around here is liquid. Until here, this point is still liquid, but here they say just become. Okay, they just become. Although D point also still liquid, but just become. So answer should be C. Is it okay? Solid. Okay, this part, they won't change the stage. So solid, still solid. Then when the temperature become constant, meaning they start to change the phase. So it will have mixing. Okay, some of them going to liquid already. Some of them still in solid. So we will have some solid and some liquid here. But until point C at here, this one is completely liquid. Just become liquid. Okay, between section C and D, this one liquid doesn't change the stage, but temperature increase until point D at here. This one is fully become liquid. Is that clear? Okay, so we go to the question number 3. So try again. No problem, try again. The graph show, you see, sometimes they will repeat. The question will repeat. Okay, the graph shows the temperature of a substance as it is heated steadily. In which part of the graph is the substance boiling? Then we try again. When it which part the graph which part of the graph is the substance boiling? Okay, Angeline, yes. Bora, yes. Emily, yes. Shu-en, scroll up a bit. Okay. So here, Zihua, yes. Okay, Daniel, try again. Where is the part for the substance boy? Shun, done? Okay, right dear. Boy. Keyword boy, see? Boys and girls, see? Boy. Keyword. When boy meanings what? Change of state. When change of state, what does it mean? Temperature constant. Okay, here from the graph A, B, C, D, only 2 sections is constant temperature. Which 2? Section B and section D. So which one is boiling? Boiling will be from liquid to gas. Right? So at here, they got 2. So this one is solid. This is liquid. Here is gas. When they are horizontal, meaning solid plus liquid. Then when they are in D, is meaning liquid plus gas. So when they boil, change of state, of course they got some missing because they haven't completely convert to gas. So our answer for this question will be donkey. Okay, is that clear? Is it okay? Angeline, okay. Sihua, okay. Daniel, yes. Okay, Megan, okay. So I move down. Xuan, done. Okay, there comes to here. A solid, so they tell you this is starting solid. So we label lah, solid. Then RS we label liquid lah. Okay. This is how the temperature change with time and it is heated constantly. Between which label points on the graph is the substance partly solid and partly liquid. Which part? Partly solid, partly liquid. Angeline, yes. Okay, how about others? Daniel, yes. Bora, yes. Dear, this part is solid plus liquid. So horizontal is changing the phase. They will have some mix of the stage. So answer should be QR, boy. Okay, we go to the next question. Zihua, okay. Question number 5. So I move to question number 5. 3, 2, 1. Okay, let's go. A piece of melting ice at 0 degrees Celsius and a beaker of boiling water are both in the lab. The lab is at 20 degrees Celsius. What is happening to the temperature of melting ice and what happened to the temperature of boiling water? What do you think? Emily, find the keyword melting, boiling. So what happened to their temperature? Temperature of melting ice, temperature of boiling water. One correct, one wrong, Emily. Any others? What is your temperature? What is happening to the temperature of melting ice and the boiling water? Angeline, yes. How about others? Zihua leh, Zihua, what is your answer? Hui Teng, your answer? Bora? Daniel, try. Keyword melting, melting. Melting is the keyword. Melt. Boil. What happened when melt? What happened to the temperature when boil? Bora, correct. Okay, dear answer it should be deng 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 deng. Zihua, yes. Okay, answer should be A. When melt and boil, Daniel, yes, correct. Melt and boil meaning what? Change of state. Again and again, change of state. When you change of state, you are no change in temperature. Temperature remain constant. Temperature remain constant. Is that clear? Okay, the rest of the questions, we continue on Saturday, which is tomorrow, Friday, one more day. 2 days later, tomorrow, the day after tomorrow.
Miss, Saturday what time?
Same times, 8 p.m. to 9:30 at night.
Okay.
Okay? So if there is no other question, then that's all for our lesson today. I will send out the worksheet. I hope that I able to complete the next chapter worksheet by tomorrow. Actually, I got the worksheet, but I want to modify it and put in more past year questions, make it more completely lah. Okay. So if there is no questions, then see you on Saturday. Everybody, bye bye.